Yo guys, welcome back to part 5 in this series on serverless. In this clip, we're going to be getting our app finished and deployed and packaged up nicely. So what we want to do essentially is just add in a couple more resources into our CloudFormation template or into our SAM template. And those are going to be our DynamoDB table that we're actually going to have up in AWS, and also some policies around that will allow the functions to actually be able to write if it's the write function and get if it's the get function. That's pretty much it. Other than that, we're just going to package things up using the SAM package command, and then we're going to use the deploy command, so the SAM deploy command, which will take everything and deploy it via CloudFormation into AWS, and we should be up and running. So jumping straight into it, here we are in the terminal again, and we have, of course, our application. One thing I do want to do is just make this a Git repository. I have an alias for this, just exclamation mark. This is a really good thing to get into the habit of. Make sure you do this the first thing so that you could do commits as you go along and revert back as needed and sort of branch out and try new things. This is something that I should have done at the very start. I'm going to do it now. Just keep this in mind when you're playing with this sort of stuff, is to do this. It's a bit obvious, but you get it. Cool. All right, so what do we have? So let's open this up in code. Here we go. We have basically everything we had last time, right? So let me just make this a little bigger. So what we want to do is we have this section here for our globals, right? So this is all well and good, and it works for testing, where we might do some local DynamoDB endpoint testing. But what I want to do is I want to have, make this a bit clearer for someone else if they're reading the template. Because just leaving null values in there is not really that helpful. It doesn't explain why it's there. So what I'm going to do is say ref AWS no value. And what this is essentially is just a way of saying it's no value. And allows the CloudFormation APIs to read it and interpret it as there's nothing actually there, so it's like null. This is for local testing, leave as no value, right? This is just for local testing, and it doesn't need to be declared for a prod. I mean, we could do fancy things where we use conditionals and stuff like that, but in this example, we'll just leave it here with this note. All right, so what else I want to do? I've got my get and my put function, so I need to declare my table in here as well, my DynamoDB table, and whatever else I want in here, right? I can put Redshift clusters or whatever I want. I mean, it's just CloudFormation, so I can create any single resource in AWS in this template. So what I'm going to do is create my DynamoDB table just down the bottom here. So DynamoDB table. Use snippets, guys. It's absolutely amazing. Everything you need, you just put it in a snippet and you just come back to it when you need it. It's so handy. So here we have the DynamoDB table. And as you can see, the type is just DynamoDB table. We can specify things like, do we want server-side encryption on? And it's just a Boolean, right? True, yes, I want everything encrypted. No extra charge, nothing. It's just amazing that you can do that these days. It's just really nice. And then we can define our attribute definition. So we're going to be using ID, right? That's the task ID is the thing we store as our attribute. And we also define our key schema as well. So we have that as ID as well, which we're only going to have that as our hash key, as our primary key, essentially. We don't need a range key. If we wanted to add a range key here that we maybe had like day of the week or something that we could use to sort, we could do that as well. But we don't really need it in this case. And we can define some provision throughput. So provision throughput, you can read a whole bunch about it. I'll put it in the description below about provision throughput and how it works. But essentially, it's our read and write capacity units for our table. So in this case, I'm not going to need to do more than 1 per second. Let's just say that for now. And the size of my writes is going to be around about less than 1 kilobyte essentially. So it's all good to just leave this as 1 and 1 for this specific use case. So that's our DynamoDB table. So one thing you think of as well is okay, so now we've defined our table. What's the name of our table? We didn't really specify a name anywhere. So when this gets created in CloudFormation, it's going to get given a name, a resource name. So you might think okay, but in our code, we're actually how do we know what table to write to, right? And if we go back and look at our code, you can see that our actual table name is hard-coded in here as tasks. But our table is not going to be called tasks. We don't actually even know what it's going to be called. So how the hell did we put it in here? So you have two options. You can actually statically define a name for a table in the resource in CloudFormation. You could do that if you like to. But I don't really care so much. And I sort of want to detach myself and sort of promote the idea of getting rid of this idea of attaching everyone to names of things. Like we used to do it with servers when we were like, oh, we got to cuddle our AD domain controller and this server and that server. They need to have these awesome names. That it's just a thing that sort of lives in the past now. So what I'm going to do is actually just say process.env table name, right? So there'll be an environment variable that'll reference the table name. And that will give us everything we need inside our query or inside our put to actually reference the table name. So I don't need to worry about it. So how do I actually get that environment variable inside the Lambda functions? Well, we're already passing in some environment variables up here. So what we can do is we can just say table name. And all that's going to be is a ref to the DynamoDB table. This is the name of the resource, right? So this is actually this resource here. And when you reference a DynamoDB table, what it will do is it'll go and populate this value with the name of that table once it's created. So that's how we're going to get the value from here into our Lambda functions, which will be referenced via the environment variables. Nice and easy. So another thing you'll notice is that we have these policies now on our function here. So you can see our put function and our get function, they have these policies assigned to them. Just before, we didn't have any policies, so I just put these here just then. And they don't actually reference anything yet. Like we haven't actually created this policy or this policy. But I put these here as like a boilerplate so that we should be able to say, if we're doing a get against our database with our get function, it should only ever have access to perform get. It should never have access to do writes. And not only that, it should only ever have access to that specific table, right, to this specific table here. So how do we go and set all that up? Well, the idea is we have this reference here, so we can go ahead and create these policies now. So if we just go, again, snippets, DynamoDB access. So here I have some access. So it's a managed policy in IAM that we're going to attach to the Lambda function. So all Lambda needs is a policy that allows it to access other services or other APIs. And we can define exactly what we want to happen in here. So down here, we can say that it's going to have DynamoDB get access. And the command we want to actually be able to execute is DynamoDB query. And then we're going to put star here for it's going to allow us to do all the query commands. And then you can see the reference to the actual resource. So DynamoDB table or Dynamo table. So we need to just fix this name up here. So we're actually referencing the exact right object. So now this is going to go and get the on of this and add it to the resource for this managed policy here. So it's going to be that whoever has this policy assigned to them will have query access to this specific table. Okay, so that's going to be really good. That's all we really need for our get access. And I can just copy and paste this. Let me just fix up this formatting down here. And we can change this to put. We can change this to put. We can change this to put. And that's all we need to do. And now we have this DynamoDB put access as well. So this is going to be responsible up here. So this is going to be the put function will have this policy. And the get function will have that policy. So we've sorted the security side of our serverless app. We've got server-side encryption enabled on our table. We've done actually a pretty good job for how quickly this is to set up. So we're pretty much ready to roll and deploy this out. So one thing we need to do now is we need to go ahead and create an S3 bucket. So I've just created an S3 bucket here. It's just called my cool app bucket SAM, right? It's a random name. You don't really need, it doesn't really matter. You just go into AWS and you just create an S3 bucket. It can be wherever, it doesn't matter. Now, essentially what we want to use this bucket for is we're going to run a command called SAM package. And what that's going to do is going to package up everything in our SAM template. And it's going to upload it somewhere for us. And this is going to be into this bucket. Now, the reason why we want to do that is because we want to have this template and all of the packaged contents referenceable and makes it very easy for a service like Lambda to just grab it from S3 and build it from there. So it's a really nice way to sort of intermediate step between your laptop and it actually being a fully fledged stack with the functions, with the tables and everything. Okay, so back in the terminal now, what we actually need to do is we need to say SAM package. And when we say SAM package, we can pass the -- template file. And then we just point it to our template.yaml, right? That is our SAM template. Then we specify an S3 bucket name, right? The actual name of the S3 bucket that you created. Mine's called my cool app bucket SAM, the one we just looked at. And then you specify an output template. Now the output template is going to be the processed version of the SAM template, right? So it's going to be the actual output of all that. And it will show it here to us, and we can have a little look at it once we've run this. So what this will do is it'll actually start to validate the template as well. It'll do a little check to make sure the template looks good, and then it will package it all up for us. And we'll have a look and sort of go through what the packaging concept means here in a second. So you can see it's doing an upload now, and it's given it a random name here. This is what it's going to be called in S3. And the reason why it's a little bit big here is because it's taken all the node modules, right? It's taken everything that I need for my specific app and packaged it all up so that Lambda has it and it's ready to roll. It's really, really simple. I don't have to think about anything. I just say SAM package. And of course, when you think about CI/CD, you're not actually running this from your laptop. Your continuous integration and deployment server and mechanisms are doing all this for you. So that's done. So successfully packaged, and we end up with this my cool app YAML, right? That's the output file that I said I wanted. So if we had a look at my cool app YAML, so you can see what it is. It's like basically the same template that we created, but it's sort of restructured it a little bit, and it's populated some of the fields for us. So namely, the one thing that it's done is it's gone in here and actually created a code URI. Like, it needs to know where the code exactly is stored. And I didn't tell it. I just said, yeah, sure, I'm just writing it here in my editor or whatever. But when I said SAM package, it's like, okay, what I'm going to do is package all this up, include these things that I need to include, and then append a reference to the template so that it knows where to find the things that it needs to find, right? They're going to have to be in that artifact, like the index, or the app.js, the node modules, all of that sort of stuff is in that artifact. So it's created that reference for us. And it's ready to roll at that point. So if you look up here, you'll actually see some output. It says, just run this command in order to create your stack. So again, it could be the next step in your CI/CD pipeline or whatever, or you can just run it from your laptop here for testing purposes. So I can run this deploy command and I can give it a stack name. And the other thing I need to do is pass this capabilities flag, which means that I'm okay with this specific CloudFormation creating IAM roles and policies for me in this specific case. It's just a safe way of saying, yeah, I'm okay with the idea of creating roles that might do things. So this is going to create a change set. And if we just open up the AWS console and we go over to CloudFormation, I've got a couple of stacks in here already that are just from other things. But here you can see my cool app, and it's being created at the moment. So create in progress. And if we actually have a look at the resources that are creating here, at the moment, it's just creating the DynamoDB table. So this is going to be the first thing that it creates. But it will go through and create all of the things that are associated with the specific app now that we've defined. And you'll also notice that what SAM's actually doing is it's creating the pieces that sort of glue these things together, like Lambda permissions and the roles that are going on behind the scenes. A few things that you shouldn't really need to worry about as a developer. If you're building an app, you just want to build it and push it and it work, right? You shouldn't have to worry about all the little bits and pieces that might have to be there in order for an app to fully functional on that operations side of things. So it's going to handle a couple of those things for us here as well. So what you can see so far is the roles that were created. So we didn't actually define the roles for the Lambda functions. We just said we want Lambda functions, like serverless functions, go. It's going to go, well, you need a role for that actually allows it to execute. What we did define, though, is some access policies that we want to attach to the function. So you can see those being created there. And you can see basically everything's done now. You can see the function role, the put function. Of course, we have two functions, right? We have the DynamoDB table. So it's looking pretty good. And then we also have the API, right? We didn't actually specify it anywhere in our CloudFormation template, but we said it is the trigger for our functions. So Sam's gone and said, well, okay, you need an API then. So it's going to create us a public API that is going to be automatically set up to trigger our functions. So here you can see it down the bottom here. It created these for us. It's done all of those resources just from that small template. So here's the output tab that we talked about. This directly correlates down to here. So outputs, and you can see we were constructing the URL of our API, and we can see that here. So we have the URL. So what we can do is we can open up Postman, and we can just paste this in. Ours was tasks, right? /tasks. And we can just do a get against our API now. I have a missing authorization token. Okay, so let's have a look at what that could be. That's because of the route. We actually said that it's mandatory to pass a parameter here. So you actually have to pass a parameter, and I got a 403 forbidden. So we could build that up a little bit and give sort of a better error message than missing token there. But if I add the 1 on there, I should get a 404 not found. Yeah, so it's actually asking the database now. And if I run this again, you'll see that cold start was the first one. So now we're going to get these like nice and quick responses here. So under 100 milliseconds is what we should be getting there and aiming for around that. So that's us querying the database. Of course, I can put something in the database as well. If I do, let's add something in. Let's do raw application. So we had task, and that was go driving, for example, and that was complete. Have I been driving today? True. So we're going to add this as task 1. So if we do our put request in here as task 1, we should get back our put with a 200 OK. And of course, we can change that output there to make that a bit more nice. That's a bit eh. But if we do a get now in our database, we get our item back. So we're actually able to perform creates and gets on our database just that easily. That was pretty simple, pretty straightforward. So that's it for this one. In the next clip, I want to talk about deployments, which will be our last one. We're going to talk about how we can do safe deployments and make that highly available with the concept of blue-green deployments for our serverless functions. All right, cheers, guys.